Excellent, excellent. Okay. I think we're just going to go with this. I'm not going to spend too much time fiddling with my setup. All right, so welcome to the first Together C and C++ presentation. We've been planning to have sort of one presentation per week, Saturday evening. And this is the first week. Hopefully we'll get some more interesting speakers on next week. I think Sam was thinking of doing a talk on language design at some point. We've got a list of talks lined up, things on this talk, debugging, language design, compilers, some security stuff. So yeah, we've got some interesting topics coming up. So stay tuned in future weeks and follow our Twitch channel if you want to stay up to date with that. Okay, so in this presentation, I'm going to talk a bit about GDB. I'm not going to assume any prior knowledge. I'm just going to assume you don't know anything about GDB, and I'm going to go sort of from no information. I'm going to explain how breakpoints work, how stepping works, general GDB quality of life tips, and then later on, I'm going to go over some more advanced features of reverse debugging, watchpoints, backtrace, configuration, and that sort of thing. And yeah, we're just going to hopefully give everyone a good understanding of how GDB works and how to use it to debug programs. So yeah, if you want to chat, you can always write in the Twitch chat. The VOD will be saved and we'll export it to YouTube afterwards. You can also talk in our Discord. And yeah, I think we've made a channel now for discussion on that. I'm not going to be checking it too rigorously, but you can always write stuff there. Okay, so GDB. Ooh. So probably worth me giving a quick intro to my whole setup. So I'm using Linux. So if that's why everything looks a bit weird, then yeah, I'm using i3 window manager. So I have these 4 sort of workspaces in the top left, switch between them like that. And yeah, this is my text editor, and then I'm going to be running GDB over here. So yeah, and Felix has posted an invite to the Discord in the chat. If you're not in the Discord, then feel free to join and get involved. All right, so what is GDB? Well, GDB stands for the GNU debugger. It essentially helps you find issues with your program. So one typical way of getting rid of problems in your program is adding loads of print statements, and that works to an extent. That's actually very effective, but it's definitely good to know how to use a program like GDB. You're not always going to be able to just fix every problem by adding print statements, especially in larger projects. You'll find that you're going to want to use some of these features that I'm going to show you today. Can I zoom in on websites and in my text editor? Whew, okay, this might take a bit of a... In my web browser, I can do that very easily. In here, it's just going to take some... yeah, let's do that. Right. Let's do that. There we go, that's zoomed in a bit. The joys of Linux. Right, so what was I saying? Yeah, printf debugging will get you very far, but especially in larger programs, you're going to run into some issues. And also, if you're doing things with recursion as well, sometimes it can get... Oh, thanks for that Alacrity tip. If you're doing recursion as well, sometimes it can get pretty tricky, because you don't want to be printing things all the time. And yeah, GDB is definitely a good tool to have in your toolkit. So you don't have to use GDB every single time to debug. There's nothing wrong with printf debugging. Personally, I use that a lot. It's often often a lot faster just to add a print statement and recompile than it is to set up GDB and context switch. Yeah, so the way GDB works, just as a general point, is that you compile your program as normal, essentially. So we can do cc, let's go to this hello program. I've just got this hello.c file in my folder. And we compile it as normal with GCC or something. Hello.c. And the crucial thing when you're using GDB is you have to compile with -g. This will add debugging symbols to the binary, this executable, so that GDB knows how to. GDB can follow the program in the source code. Otherwise, it doesn't know anything about your source code. It can just see the executable. So you have to use -g if you want to get anything useful out of this. So you do that, and then you simply run GDB on the executable, GDB hello. And actually, the first time you run GDB, you're going to be greeted with a lovely message that looks like this. This huge, software license thing. If you don't want to see that every single time, then what you can do is you can just do -q, and that will get rid of it. Or what I've done is here is I've just aliased GDB to GDB-q. So I'd recommend doing that. And we'll go over some more configuration tips later. But yeah, so you just run GDB hello, and then now you're in GDB. So nothing's actually run yet, nothing's happened. It's just loaded in the file hello. And then I'll just give you a quick example of how this debugging things work. So let's put a breakpoint on main. What this does is it tells GDB when execution gets to main here, just stop running, okay? So we've told GDB to stop running when we reach main, but now we need to actually start the program. So to do that, we just type R, and now you can see it's stopped on this line here. Then what we can do is we can step over this line. So you can use next, and then you can see we're on line 12 now, and then next again. And you don't have to retype the previous command. If you just hit enter, then GDB will keep going with the last one you wrote. And another trick is instead of typing out the full words a lot of the time, you can just type like one letter. So N will usually, N is the same as next. It's just a short form. So yeah, we can step through our program with N. We can also show some more context to where we are in our program with list. What else can we do? Yes, so when we get down to this foo call here, what you're going to see is if I press N, it's going to completely skip over this whole call, and it's going to go on to the next one. That's not always what you want. I mean, sometimes you want to follow the execution inside here. So in order to do that, you type step or equivalently S, and then now you can see we're executing from inside here. Right, let's have a look. Yeah, so I'll talk a bit about optimizations later. Compiling with O0 doesn't actually gain you anything because that is the default. Compiling with OG is different to O0. So yeah, OG is recommended if you're debugging, but I'm just going to keep it simple for now, and I'll explain more about optimizations later. Okay, so once you're done debugging, you can just hit Q or quit, and then it will ask you to confirm your choice if you really want to quit. And yeah, so that's in a nutshell how GDB works. You can see we're just sort of stepping through the execution of a program and seeing exactly what's happening. And one thing that wasn't completely obvious here is as I stepped over this printf line, it actually, you can see the output of your program in here. So it's always good. How do you quit? Quit with Q or quit. And then it will prompt you and you just press Y. Okay. So what -g actually does, if I just compile this again without -g, and then we look at, what the program actually contains, So there's no debugging information here. I mean, it's not obvious at all, but there's no debugging information in here. If you compile with -g, you'll see that you have these sort of .debug key ranges, and this tells GDB how to associate instructions in the executable with lines of code in your program, lines of source code in your program. So if we go again without -g and then we run hello, what you'll see is, yeah, it says no debugging symbols found in hello. And then if we try and, like, we can break main, so some things will sort of work. It knows about the symbols in your program, which is generally function names. So we can still break on main, but if you do next, it's not going to work. It's because it doesn't have any line number information. It doesn't have that association executable between instructions and source code. So you need to compile with -g in order for things to work. Yeah, function names that have external linkage. And that's because those symbols will go in the symtab section, and this is omitted even if you don't compile with -g. So you can debug things without -g to some extent, but in order to have the full experience, you really want to have -g in there. Okay. Yeah, so just in general, getting help is probably the best place. Just go to this link in your browser. I can in chat. Actually, maybe not, because I got Twitch open on my other computer. But yeah, so there's this link. For some reason, well, not for some reason, all the GNU tools, they work really weirdly. So you can't actually get much out of the man page here. It's pretty useless. Yeah, there's not really much in this man page. But then if you do info GDB, a whole load of information. It's basically the same as the same as this website here. Yeah, you can see this is basically the same thing. This is pretty horrible to navigate, so I don't really like that. But I debug with O3 in hopes that I2 maybe. Yeah, fair enough. Okay, let's see what I was going to talk about. Oh yeah, so that's sort of, this is how you find the manuals and stuff. We go back into GDB. There's obviously help, and there's some more information at the bottom here, so you can help all. Ah yeah, and this is a good thing to mention. So a lot of the time with GDB, if you ask it to do something and there's too much output, it will go into this sort of paging mode, pagination mode, so that you can see all of it at once. And we can either like quit, so stop seeing the rest of the output, or we can press C and it will sort of disable that mode, and then we can see all of it like that. I'll go over how to remove that later, but it's worth knowing how to navigate that. I sort of disabled all my configuration to begin with, just so people will be able to match up their expectations when they try and run GDB themselves. Another useful thing is you can use this command here, apropos, and this is sort of fuzzy help. So you can type in a string and it will show all the different help items that are related to that string. So if we type like, I don't know, thread, then we get all the stuff about threads. And yeah, so basically we can search help a lot easier with that. Other useful tips at this point, you can use the up arrow to access previous commands. If you just want the last command, then remember you can just hit enter and it will automatically read this command. But if you want to go to ones before that, then you just up and down arrows like a normal shell. Yeah, apropos is a very weird name. Apropos. See what it says. Search for commands. Let's see what the help says. Search for command. Yeah, so you can use a regular expression here. Right. Okay, the next thing I want to show is, yeah, it's TUI mode. So what we had before, where it was just showing one line of code at a time, was pretty horrible. So instead, what we can do is go into this thing called TUI mode. And this is much nicer. This is, probably what you want to be using. And if we go ahead and break on main and run the program again, you can actually see exactly where it's executing, and it's generally a lot nicer. You can also press Control X, Control A to get into this mode. So Control X, sorry, it's not Control X, Control A, it's Control X, then release, and then A. So Control X, and then A. And that will switch between those modes. Other things we can do in this mode is we can look at the assembly with layout ASM. Go back to the previous one with layout source. We can also get a split layout where it'll show us both. And then if we sort of step over here, see the corresponding instruction for this line of code. This can be quite useful sometimes. Oh yeah, here's a good thing. So this is printed down here. GDB in TUI mode gets very confused. You try and print things while you're in TUI mode. So if this ever happens, you have to press Control L. I think that will also do it. Let's see. Yeah, you can also just type a refresh, but Control L is a good thing to do. And yeah, if you're not in TUI mode, you can just use list, and that will show you the few lines of code around executing. But I do like TUI mode. I definitely recommend using that. It's much nicer than typing list every 5 seconds and opening it as a whole line of code. Okay, so TUI. TUI stands for Text User Interface. So the idea is that it's you have there's also layout regs. A step. Yeah, so that will show you the registers here. That pointer, such. TUI, yes, TUI stands for Text User Interface. And the idea is it's in contrast to a GUI, Graphical User Interface. So, I mean, because it's running in the terminal, it's sort of a text interface. Vim is technically a TUI, I suppose. But yeah. Right. Okay, so let me explain a little bit more about breakpoints. So let's go back into TUI mode here. So we can, as well as setting breakpoints on functions, we can also set breakpoints on lines. So we can set a breakpoint on line 16 if we want. E16, you can just type break. And then maybe we don't want to sort of individually step over all these lines. We just want to skip to the next breakpoint. We can type continue or just C. And that will take us right there. We can also look at all the breakpoints that are currently active. Info break. The one here corresponds to this first breakpoint, and 2 corresponds to this one here. And we can delete break. Let's just delete breakpoint 1 with D1. And if we rerun the program, you'll see that it's just going to go straight to this printf. There we go. And yeah, another good thing to mention, if you're in TUI mode, the terminal sort of captures your up and down arrow keys. So you can't use up and down to access previous commands. Instead, you have to use Control P and Control N. So I'm just pressing Control P previous and Control N for next. But the up and down arrows by default will source code here. Okay, deleting breakpoints, we've done that. You can also set temporary breakpoints. So let's say we only want to break. So yeah, we only want to break on our function foo the first time that we reach it. We can do TB for temporary breakpoint, foo. And then continue. We're now in foo, and if we continue again, It's not going to break in foo because the breakpoint is now deleted. A temporary breakpoint is just the same as setting a breakpoint, and then as soon as you hit it, just deleting it. And then there's also a special case for main. If we just go back to here, it's very common to sort of type b main and then run the program. Instead, you can just do start, and that's exactly the same thing. It just sets a temporary breakpoint. There's also conditional breakpoints. So maybe we only want to break when, maybe we're in this function foo, and we only want to break when the value is 1 or something. We can do that, b foo if y equals 1. Right, and then, yeah, then we're now in foo, y equals 1, surprisingly, amazingly. Another thing to go over at this point is probably backtrace, I guess. So type BT and it will tell you, it'll give you a full backtrace of where your program's executed. So you can see that we're currently, this 0 means we're currently in foo on line 5. And this was called from hello.c line 19. So yeah, so our conditional breakpoint did the right thing and skipped over this first one and only broke when y equals 1. You can also type BT1 or BT and that will only show you the last sort of n number of stack frames. That can be very useful if you have a huge call stack and you only care about the top 2. Yeah, I'll talk about sort of expression evaluation in a minute, I think. In terms of stepping, some useful stuff to go over is probably, as well as next. Oh yeah, I've already said that, haven't I? You can step into the function with S, and then you can also run the program until the function finishes. So this is especially useful if you accidentally step into something you didn't mean to step into. You can just type finish. I think F, same thing. Oops. No. But yeah, that will get you out of the function you're currently executing. And there's also return, which is a bit weird. I think return sort of makes the function, forces the function to return immediately. A bit weird. Generally don't need that, but just remember that if you want to execute until the return command is finished, not return. Okay. So have we got any questions at this point? Oh, how does viewing these registers help you debug? I get we can see this stuff, but for a beginner, what's the benefit? That's a good question. The registers, looking at the registers is pretty much irrelevant in most cases, I'd say. It's really not very useful. What's sometimes useful is if you get a weird crash and you need to look at what's on the stack, might be useful. It's also useful if you have some handwritten assembly in your program, or if you're, well, that's another thing, yeah, because if I can show it right now, you step into a libc function like printf. I don't think it's gonna have, oh, that's not, oh, that, okay. Yeah, so the reason why this isn't working is because the libc functions, they don't have debug information, unlike the rest of our program. So if you ask it to sort of step into the function, it gets a bit spooked. But instead, what you can do is let's go to our ASM view. We don't have any information about the source of printf. We can still look at the instructions, and we can step over the instructions like that using SI. So the registers can be useful if you don't have the source code and you're just looking at this assembly view here. There's also NI, which will skip over the call instruction. But yeah, I mean, it depends what you're debugging, I'd say. But in most cases, you really don't need to look at the registers. It's very useful. But it's there if you need. What Vim plugins are you using for C++? Because I can post my private. I am using. So this thing on the side is called nvim tree, and then I'm using tree sitter, syntax highlighting. I'm using this galaxy line at the bottom here. Yeah, I've got a bunch of MISC plugins. I suppose I could make my configuration public if people really wanted to see it, but it's quite minimal. I don't have autocomplete or anything set up at the moment, so I wouldn't necessarily recommend trying to copy back set. Put it that way. Any other questions at this stage? All right, I will continue. So the next thing I want to go over is Watchpoints. So let's say you want to figure out, maybe this is a good time to go up to the other program here. So go to, yeah, so I've got this little example program here, which is sort of, it reads a string standard input. And it checks if the braces are balanced. So you can see here, it checks if, your square bracket has a matching square bracket in the right place. So, it's pretty basic. How do I print variables? I will get to that very shortly. Actually, maybe I'll just explain that now. Thing to explain. Yeah, so I have this simple program here. And let's just don't trust that. Ooh. Make. Okay. So print variables very simply with P for print. So you can print S, see it's null, print argc and such. There's also info locals, I think it is. Yeah, info locals. This will show you all local variables. Not very interesting at the moment because only one local variable. Also info args, show you arguments. If we go into test, function test, then what's happening? Oh yeah, see what's happening. So yeah, so because this program reads from standard input, sorry about that happened. Yeah, get line here. This reads from standard input. You just sort of try and run the program, it's going to block. And in order to, provide input, you just type like that, and you can see it's exited normally while also messing up the screen. Remember, Control L to clean everything up. Yeah, printing variables with P, info locals, info args to show arguments. I think if there's any other thing I should say about printing at this moment, probably not. I think I'm going to explain watch points now. So, got this variable depth here. Just keeps track of how many braces we're expecting to find. So once it's read one left bracket, the depth will increase, and then once it's read the corresponding right bracket, depth will decrease here. So we might want to see where exactly this variable is being modified. This is particularly useful if you're in a very long program and have some global variable. It's in like a 10,000 line source code file. You have no idea where it's being modified. Could be one of a billion places. What you can do is you can set point on depth, and then yeah, it will tell you set a hardware watch point on depth. You run the program again, let's type something in, and it very handily tells you the old value of depth before it hit the watch point was 0, and then after we executed this line, the new value is 1. And it also tells you the line that it changed on. And that will just, that watch point will trigger when the value of the variable is changed. You also set a watch point when the value is red with R watch. There's also a watch for both reads and writes. So by default, watch will only watch the writes to the variable depth. Another useful thing is by default, watch will sort of look at the expression that you give it. So I don't have a good example to hand, but if we had like a pointer, we wanted to watch the value p dereferenced a, then it would sort of check this expression anytime you change p as well. But sometimes that's not what you want. Sometimes you just want to watch the actual the memory address of a. I'm not explaining this very well, but essentially GDB will when you say p a, GDB will treat this as you treat it, and it will really figure out where that PA is changing in your source code, and it will not care about the memory addresses so much. If you want to care about the memory address, then you have to pass location or -l, and that will watch the address of A. That's very useful when dealing with pointers. What else is there to say? So I think I'll talk about configuration. So GDB is, I mean, as you've seen with this message here, I mean, GDB is sort of a bit rough around the edges. Some configuration. Oh, how to unset a watch point? That's a good question. So a watch point, it can be deleted just like a normal breakpoint. So a watch point at depth. Continue, type something in. Then type info watch. It'll show you all the watch points. And this is watch point number 2. It'll also show up if you install the breakpoints. And yeah, you just type D2 and it will keep going. Oh, good question. Lovely. Yeah, so configuring GDB is usually done through this file here, .gdb init in your home directory. So I've got some options here that I'd recommend people set. First one is changing the disassembly from the syntax to disassembly from AT&T syntax to Intel syntax. It's more down to personal preference, but I think it's also a lot more intuitive for beginners. To show you the difference here quickly. Yeah, so this is the default AT&T, and you can see with instructions like this, LEA, you get this weird, like, yeah, this weird thing. Whereas if you use Intel syntax, you would get this expression here, and it tells you explicitly, you're adding to the value of RIP. And it gets a lot more complicated in AT&T when you like scaling, that sort of thing. So I think this is a lot more intuitive for beginners. Have to be careful because the order of the operands, the order of the operand every instruction's switched. RIP, that is the instruction pointer. So if we, lovely, show up in there. There's probably a way to get it to show. I don't know. It's not switched, it's forward. Yeah, well, anyway, RIP is the value of the instruction pointer. So for this instruction, it's this thing here. It's just the address in memory that you're currently executing at. It's not really well, it's not a general purpose register. Same way that RAX and RBX and stuff are. Some instructions will allow you to offset based on RIP. It does get a little bit complicated, but yeah, it's just the instruction. All right, let's go back to DBNet. So the next thing is this nation. I mainly recommend you disable because, I mean, if you're living in the 21st century, you probably have the ability to scroll on your terminal. So if you remember from before, we had that thing at the bottom asking us if we wanted to continue or quit or whatever, but now we've disabled that and you can just, scroll with a mouse or whatever you want. Also this will disable prompts for certain things. Really useful one is history save. It'll save commands between invocations of GDB. So if you type a command and then you quit GDB, it will be able to remember. You can just press the up arrow to access that last command next time you open GDB. There's also this one here, which will give you access to like bash style expansion in when you're messing around with commands. So I think you could play around with this a bit. I don't use this because I don't use bash. Let's start and do that. That's gonna the last command. Yeah, got it's 2 for 2 commands ago. That's the wrong one. Something like that. But basically that works the same way as bash. If you're used to using that sort of thing in bash, then that's quite nice. But I just keep this disabled because I don't really use bash, so I don't really know what's going on. What else should I cover? Other useful things when printing variables. So as well as p, you can also use x. So x is more low level and x doesn't really try and understand the type of what you're printing. So give an example. If we try and print 0, it will display this as a string. Whereas with x, it doesn't know what's going on. It knows it just tries to print out the address that it points to. Sorry, this is the value of the data that it points to. So you can see that ASCII / and then H and then O, and you can also ask it. You can also tell it explicitly that it's a string, something like that. Yeah, there we go. So x / followed by the format of the data you're trying to print. You can also ask it to print as like a word. So I don't really know what this is going to do. Oh. Show printing arbitrary life. I wish. This is CPU usage. Yeah, so I've got volume, disk space remaining, CPU usage, and date and stuff. One thing that X is really useful for is examining the value of examining the stack. So do like X that, yeah. So we're just asking it to print like 4 bytes, 4B, and then SP is the stack pointer. So this will print the top 4 bytes in the stack. And you can also ask it for S4. I don't actually know. Let's see what it says. yeah, so octal, hex, decimal, 9 decimal, address destruction. Yeah, so if we had a variable and we wanted to print it out as hex, we do x or something, or x/d, and the expression you want to print. You can also do that though. Yeah, P also accepts a format. So P does try and understand the type of what you're trying to print by default, whereas X just sort of is like a memory dump. It doesn't know anything about the type. But yeah, it's very useful for examining the values that are under the current stack pointer and such. And there's also, oh yeah, so one thing you may have noticed as we're going through just printing things, it's like if we print S, there's this $sign, $2, and this is like a temporary variable used to refer to things. So if we print something else, this is now assigned a value assigned to $3, and we can reference it just like that. We can also reference the previous one, I think, just the $sign. Yeah. And then if you ever forget what you've written in the past, you can go values, and that will show you all of the temporary variables you print out from before. Right. Another thing that might be useful for some is this find command. Find. Yeah, find. So what this does is you give it a start address and an end address, thing you're trying to search for, and it will try and search for that between those two addresses. So like, let's see if we print argv0. This is going to be a terrible example, but if just go like 3 characters later, I'm going to find the character H or something. Yeah, it's showing that it's found this address. This really just searches through some memory, and you give an expression here. You can give it a complicated as well as just printing out basic variables. You can also print. You can also get GDB to execute more complicated functions. So I don't have a. Let's think of something. So go here, make a function, add one. So we don't actually call this function anywhere in code, but I'm pretty sure, yeah, so we just added one. We've called add one there. And now if we look at the value of depth, it's going to be keep adding. Yeah, so you can actually execute arbitrary code, which is really nice when printing things. It does a sort of just-in-time compilation, and crucially, it takes into account the side effects of your functions and things correctly. So that is extremely useful. I think one general point I'd make at this stage is if you don't. Sometimes if you're in a huge program, it's really useful just to open the debugger, play around with it, even if there's no actual bugs. So, for example, I started a new job a few weeks ago, and I was looking around their massive code base. I was trying to figure out where this function was called, and instead of trawling through the code and trying to use grep to figure out where it's called from, what you can do is you can simply just open up the debugger, set a breakpoint on the line you care about, and then just use a backtrace and it will tell you exactly where it's called from. So that's very handy. Just in general, yeah, debuggers are not only for debugging things. Debuggers are great just for navigating. Any questions at this stage? Second. Right. Let's chat or not. Okay. So yeah, people earlier were talking about optimizations, how that affects things. So going to my make file here. I'm just compiling with -g. All it does is add debugging information. It doesn't change the level of optimization that's applied to your program. If you do start applying optimizations and you still want debugging information, then what you'll find is that when you try and step over things, it's going to jump around the place. It's not going to go top to bottom. It's going to sort of jump back and forth. It can get very confusing. Also, printing variables, you sometimes see that they'll get optimized out. So just generally, if you're trying to debug things, and you can, it's a lot better to debug with O0, which is the default. You can also actually increase the amount of debug information compared to -g. You just have -g GDB3, I think. That will give you more debugging information. And that keeps the values stuff. Same with Alright, so I think the last thing I want to go over is reverse debugging, which is GDB3 any different from 3? I don't know. I don't actually know. I assume it is different. Look it up. Oh, I don't know. Well, as well as GDB, I think some compilers Lang, but there's also LLD, like -g LLDB. I think GDB will possibly emit information which is more tailored to than other debuggers. But I mean, in this space, GDB is definitely the best. Like compared to LLDB, GDB has a lot more features. So, for example, one thing that LLDB does not have is debugging, which I'll try and show now. If we just go back into our program. So a lot of the time, your program crashes. You don't just want to, well, because when the program crashes, you obviously can't keep stepping, you can't keep executing through the program. You can't execute backwards. But what you can do is enable this thing called reverse debugging. You can tell GDB to start recording the whole state of your program, and then you can step through in reverse if you need. So as well as stepping forward, you can also step backwards. So probably easiest if I just show. So start and type record, or we step through. You can also step backwards, reverse next, go backwards, we can go forwards again. And yeah, we can't go forwards anymore. Sorry, we can't go back anymore because that was before the point we started. We just keep trying to go back. It will complain. We weren't recording before that point. You can also make it so that when you press, if you really need to debug a lot backwards, you can just change the execution direction. Set exec direction reverse. that now. Except now the normal commands like next and step will just take me backwards. So if I do that, is this going forwards? I don't know. But yeah, so that's useful. Core dumps. Core dumps are a good thing to mention. I don't have core dumps enabled right now. I'm not really gonna try and figure out how to use that, but that is definitely something worth mentioning. So what you can do is enable core dumps on your computer, and then when a program crashes, it will create this core dump file. It will just drop this core dump file, which is essentially the state of the program when it's crashed. And then what you can do is you can start core dump file, and then this will load you in the context of where it's just crashed. So you can use that to get a backtrace and print variables. So that can be quite useful. Yeah, you have to enable core dumps on your system. So that is something to keep in mind. Other things I should mention. So GDB also has a built-in Python interpreter. This is really useful if you want to do any more complex scripting. So like, well, Python print. Yeah, so you can just execute arbitrary Python. There's also this V module here. Yeah, there's this GDB module, and you can access the GDB's API through that. You can set breakpoints from Python, step over things from Python, and that's generally very useful if you need to do some more complicated debug. You can also add these pretty printers. So this is especially useful in like C++ when you have types and can't just x on your variable because it might not know how to print that type. I mean, it'll have a good go at trying to print it, but sometimes you want a nicely formatted date or something. You can just write a little bit of Python, plug it into GDB, and that will into P command so that you can view that nicely. But yeah, I mean, this is a full Python interpreter, so you can do very complicated logic, anything you want basically. There's loads of features here. I haven't really explored this too much, so you're probably better exploring this on your own. But definitely something good to know. Okay, as well as GDB, one of the good things to mention for debugging your programs, if you don't already know, there's probably want to enable ASAN. So this here will enable address sanitizer, undefined behavior sanitizer. And what they do is check your program for things like invalid pointer accesses and memory leaks, like integer overflow and stuff like that. Very useful to have when you're just developing normally. If no inline GDB, yeah, I think I think by default, I don't know if no emit frame does the default. I mean, certainly if you don't have optimizations enabled, then you don't need those flags. You don't really need those flags. Optimizations disabled. But if you do want O3, then it can be useful to disable inline omitting frame points like that. I seem to remember something about ASAN not playing well with GDB. I'm remembering correctly. I think you are remembering correctly. Let's find out. Right. see. And is disabled when running. Yeah, Valgrind definitely does not like ASAN. Just to be fine. Yeah, it seems to be fine. I don't have Valgrind installed. Let's install Valgrind real quick. Yeah, Valgrind is also similar to Rest Sanitizer and it checks all your memory accesses. Well, Valgrind checks all your memory accesses to make sure that they're going to the right place, so that's a lot slower. So I definitely recommend using Address Sanitizer, Client Behavior Sanitizer. Yeah, so if you try and use Valgrind with Sanitizer, they'll complain, but I think GDB is alright. Disabled or anything? Yeah. Okay. Any other questions at this time? Valgrind has the benefit of being modified. Not entirely sure what you mean by modified. Oh, you mean without changing your compilation flags? Yeah, that's definitely true. That's definitely true. Yeah, I mean, generally, if you're trying to debug something, you probably have access to the source code. A bit weird. I much prefer using ASAN when possible. It's a lot faster. The output is a lot nicer as well, I find. But Valgrind is basically a full-on emulator. Like Valgrind can also instrument. It can also tell you how much memory you're using. You can also use it for profiling as well. Cache. So you can get a really nice profile from Valgrind. So yeah, it does a lot more, a lot slower. But my microphone cuts off sometimes. I apologize. I mean, I'm pretty much at the end of the stream, but I'll try and fix that. Address sanitizer are better at catching bugs when you least expect them. Yeah. I mean, one problem with the sanitizer is that not very good at. I don't think it actually at all catch utilized memory. So address sanitizer just checks that your accesses are too valid. But if you have some uninitialized memory at that location, not tell you anything. Clang has this thing called which you can enable, but you can't enable it at the same time as a. There's a bit of a downside. But this will catch uninitialized. Yeah, sometimes with ASAN, if you out of bounds, I think Jack. Yeah, ASAN isn't completely bulletproof. Valgrind will catch more problems, but it's slower. There's also three. Oh, I'm sorry. Worse in what way? There's also thread sanitizer, which is oh dear. How about that? How about now? Okay. Yeah, thread sanitizer will tell you if you have race conditions in your code. Again, it's not 100% effective, but it does catch some things. I don't think GCC can use msan. It can. ASAN won't help you if you have a custom allocator that does pooling or something similar. Yeah, that's true. Yeah, ASAN pretty much expects you to be using the heap directly through malloc and such. Or through new in C++. Yeah, pretty much everything I've said also applies to C++. This is not just C, and you can also debug like Rust programs. If you're using Rust, I think there's this Rust GDB wrapper. Yeah, that provides some Rust specific things, and syntax highlighting, I think. From C is a good C analysis tool. I've never heard of that. Interesting. This looks like a static analyzer similar to like PVS Studio and such. But yeah, there's a lot of good tools. I think if you're using a custom allocator, you might be able to. I'm trying to think if you can hook into ASAN at all. Yeah, I think if you're using a custom allocator, you just kind of have to accept the fact that the debugging quality of error messages you get is not going to be as good. It's common to do things like write specific values, like magic values, to memory addresses that you haven't initialized if you're making a custom allocator. So if you could write like OX dead beef to every single address, then if your program crashes on that address, then you know, oh, this has probably come from the allocator that I've made and probably accessing out of bounds, stuff like that. It's quite useful. Yeah, any final questions or thoughts? I think I've pretty much covered everything I want to cover. Any questions about my setup or anything? Yeah, no worries. Yeah, we'll try and get the VOD exported to YouTube, and hopefully there's an interesting talk next week. Yeah. Opinion on Valgrind GDB. What do you mean? I've never heard of this. Valgrind GDB. Is this a thing? I don't know what you mean when you say Valgrind GDB. I mean, I know what Valgrind is. Thank you. Yeah, I've just tried to make this a very condensed exposition of GDB's features and random things that are useful. Yeah, I think I did mention that. If you just hit enter with an empty command, it repeats the last one. Cool, okay. It's running Valgrind but has a built-in GDB server. Oh, interesting. Yes, that's the other thing with GDB is you can GDB. You can attach to processes, to remote processes, so maybe they're not even, maybe the process you're trying to debug isn't even on your computer. With this stuff here. And yeah, if you like, for example, if you're writing an operating system or something, then you can implement a GDB server, and that will sort of understand the commands that GDB tries to send it, and you can attach to that with GDB. So even though GDB isn't able to like directly manipulate the memory of that of the OS or whatever, you could GDB would send a packet to the OS, and the OS would read that and then manipulate the memory. Yeah, QEMU provides GDB server, so you can run the GDB server on QEMU with -s. So GDB is very flexible. It's very good for like remote, for debugging embedded stuff as well, as long as you have a GDB server. And I guess with Valgrind as well, you can attach GDB to that, as he was saying. Anything I missed? It'll break on the line when you use uninitialized memory and such. Yeah, that's nice. I guess you could get the same kind of effect if you ran msan, although that's probably disabled. Anyway, right. Yeah, thank you for coming, and I'm going to end the stream now. So bye.